recognizing the importance to bringing these experiences earlier and earlier in the process. So in the case of, and we're looking at turnkey solutions, in this case, for Revit, and we found that there's been a growth of adoption in the office, but also as an effective decision-making tool to quickly understand the spatial and material aspects of early design. So, in the master plan, the facility master plan for Cedars Sinai Medical Center, they've embarked on an advanced technology surgical suite in the fourth floor, the shelf fourth floor of the Advanced Health Sciences Building, along with co-architects. And we started engaging the client through the landscape model, and was able to create buy-in and build confidence with some of the key stakeholders, and getting them, more of an impression of the space, the materiality of the space, directly from the building information model. But we quickly realized that we really need to delve a little deeper and create a level of interaction that was kind of more engaged. And so we started to look at building a fully customized interactive experience, focusing on one of the offer experience.
So we have created an immersive and interactive architectural experience through virtual operating rooms. Since operating rooms are pretty common in our office as a room type we design, and also making the physical mock-ups are pretty expensive. So that was like the first attempt of replacing a physical notion within the realm of architecture. So in the experience, we placed two different views. The first one is the view the user in the virtual environment sees. So the other view is the overall axiom view. We placed those two views since we want to have people outside of the virtual operating room can access what's happening within the room, so in different perspectives. And also there's a library of objects, so the user can place or remove objects from library or the room. So also in terms of the design aspect of an operating room, probably the most important part is the ceiling for an architect. So we have different light conditions, different ceiling light conditions you can toggle between, and also transparency control over some of the transparent materials. So the system in the background looks for flashing objects, and if flashing happens, it gives you both visual and also a haptic feedback. So in this case, the haptic feedback is a vibration of the virtual headset controller. And also it's a multi-user experience. Think like an online game, so people can join sessions from different environments. And as you see, that's ThinkSphere is me actually. It asks your name in the beginning, so you know who people are within the room. So thanks to the technology of HTC Vive, you can walk also physically, not just teleporting yourself or as in your Xbox controller. You can walk physically. The accuracy, the level of accuracy, I think it's like below 1 inch, so it's pretty accurate. And yeah, you see my think pad there. So you can grab and manipulate objects. Also fine-tune them, because we're talking about accuracy here. This is the library. You drag and drop objects. So there's a difference between manipulating a boom and also an object. It gives a visual feedback as turning flashing element into red. So now today's technology allows 2 people within the same room, but it actually supports up to 20 people in the same virtual space, but they have to be in different, separate physical spaces. So far, we have 5 different operating rooms within our virtual catalog to explore different design decisions we already made and also we're making. Since it's a living creature, it's not a everything done thing. So today, Mr. Russell is here to give us his frank feedback about what we did, what we've done with the operating room within the Cedars Sinai project.
Okay, well, thanks very much. I'll just give you a quick idea. This is the Women's Build Simulation Centre at Cedars Sinai. It's about a $35 million investment, which really takes patient safety to the next level. What it's doing is it's creating an environment where physicians, nurses, and other healthcare providers can actually spend much of their time practicing clinical procedures, techniques, teamwork, communication, working together in a simulated environment. And we use different modalities. We're using an actual environment, but we're also using a selection and developing selections of virtual environments which have the option of engaging people much more widely. The centre you can actually see on screen and have the poster move forward. It actually has a number of clinical environments. One of them is an operating room. There's ICUs, obstetric rooms, trauma rooms, NICU environments. And the real difference to what Cedars Sinai has done working with the architects is to develop an environment which is an exact replica of what happens in the actual clinical environment. So all the rooms are fully functional, fully working. So when you walk into these simulated environments, it's an exact copy of what they walk into every single day. And there's a really good example of this. I went to Brazil recently and I was taken on this helicopter flight simulator, and it was a completely immersive experience where you were taking off and trying to land on an oil rig in the middle of the North Sea, and it was so engaging and it felt so real, and I was feeling physically sick at the end of it. It was quite incredible. But if we just go back a moment, so we look at our friend there who's laying on the bed with a tube hanging out of his mouth. They cost about $100,000 each, and we have about 24 of these. You know, we can create so many of these types of things using virtual reality and using AR as alternatives in certain situations. So we can increase our flexibility, we can increase the availability of education to our clinicians by using technology which is developing. So working with CO and the continuing relationship which we've actually got here, we're actually looking at developing simulated environments and developing rooms which have got direct end user feedback. It's a consistent problem you hear from clinical teams that the room is terrible in this way or it's terrible in that way and it doesn't work. And sometimes it makes you wonder how much engagement has been previously in the past of the end user who's physically using the space every single day of the week. So we spent a considerable amount of time doing 10 human factor evaluations with clinical teams. And what you can see on the screen is a huge selection of different sticky bits of paper everywhere, and which has been great. And what we're hoping to see is an operating room which meets these sort of end user requirements. But we're also looking at how the VR approach can offer us a greater solution to achieving what we want to achieve. So when I'm going back to the example of the helicopter simulator that we went on in Brazil, that felt completely realistic. It felt immersive. It felt as if we were there. That's exactly what we're trying to do in healthcare simulation. In healthcare simulation, we're trying to give somebody an experience that they believe is real. Give them an experience which they're going to remember and which can replicate, for example, human surgery. So already for years we've been doing appendectomies and robotic surgery and bronchoscopies and all sorts of different types of clinical procedures, but the real interest and the real connection between the simulation environment and the room design is how can we make greater use of that technology to actually enhance the learning, to enhance the operational planning, and to enhance the sort of development of new areas. So you can see some examples of some of the other virtual technology. On the right, you can see a virtual dissection table. So we're actually able to cut through these virtual people and actually go through all the different layers of the human body. We're actually able to take real CT scans and actually see all of the various pathologies and problems which may exist. And some of the fabulous stuff here is that we're actually able to take scans of real human people. We're actually able to insert those scans into simulators, and our surgical staff can actually do surgery before doing surgery on you. They can take your scan, they can do virtual surgery, they can work together as a team, and it can be that realistic. So, working with civil architects, developing environmental spaces, doing human factor evaluations, deciding whether the environment works for what we need, and also trying to use it from an operational management perspective. So the interest and the way we're seeing VR developing, and also looking at the use of AR and how can AR be used to make something far more realistic and make it far more believable for the clinicians is something which is expanding. So this centre sees about 2,500 people every single month coming through, physicians, nurses, who are practicing in a simulated environment prior to ever touching a real person. It's one of the busiest centres in the US. And again, the mannequin there, the real operating room. Hopefully we'll get from this, and then we'll start to see this being translated into that virtual environment, so we can start creating the sort of diversity which we want to achieve.
Right, and I think we also see a lot of potential in using augmented reality to start to drive the design process, recognizing that a lot of the technology, including things like the HoloLens, are very early, really more development tools. So maybe a number of years before they're really production ready, but we're kind of starting to explore early on.
So, as a mixed reality application, we developed this solar analysis app for Microsoft HoloLens. You see the designer can create some of the virtual elements of the floor plan and puts them to the corresponding spot, and it drops the virtual shadow on your tracing paper so you can sketch it. And so as you saw, it has a date and solar calculation slider, so you can switch between like summer, winter, or spring, and it's also location aware. So in the beginning, you tell it with some voice commands your location, and it starts that algorithm running in the background. So at the end, you have all your data recorded like old-fashioned. Yeah, from digital background. This is how we actually do the shifting. It's not like right after the day, so it's more coming gradually, but still, we need to keep some of the part of what we have already.
So another thing, over the past year or so, we've been looking at gathering some of our early programming tools, and making them web-based, kind of all under the umbrella of a website that we use internally. And we started this effort and started to look at different ways of visualizing the data. So to kind of take you through some of the Q&A, this is in the case of a medical education, medical school, looking at like the class size, the cohort size for the school. It kind of quickly goes to a straw program, an overall program, which we've used with clients. We started to test this for a new medical school at UNLV, and with a couple sessions, we were able to get some really quick decision making. So here's here's some benchmarking data across other universities, where the kind of decision making falls in the average or above average, also for square foot per student. So it's kind of like within a few minutes, clients would get some instantaneous feedback about the kind of decisions they're making, and then drilling down into individual block spaces and examples from past projects of lecture halls, learning studios, for medical education. And again, as a way to kind of like gather all these tools and ways of visualizing we've had before, and also drawing affinities, so kind of interactive bubble diagrams of the spaces. So we've looked to extend this, the data that we're producing online into a Microsoft HoloLens now. And in this case, we're pulling the block data that we're generating there directly from the website and starting to allow the designers through simple gestural hand gestures reconfigure the makeup of the program, and again, sort of like what I was showing before, record it in an analog fashion. So it's kind of going from digital back to analog. And in this case, examining the program at a tabletop scale and also at an eye level. So there's different modes of scale and interaction that can occur that we see happening, potentially happening in mixed reality and augmented reality.
So, as a wrap-up, for us, the future of VR in our industry actually is relying on the higher level of interaction, since it would bring the decision-making process from like early to an early stage of a whole design experience. So that could actually bring us also a replacement of physical models, and also more client engagement.
And even though we're kind of exploring these virtual decision-making tools in design, now that we're sharing these with clients, like Russell, we're finding that there's a usefulness beyond design and construction into occupancy, which is really quite interesting.
Thank you very much.
Right now it's really just a prototype, and we've kind of tested it internally. It's not a point where we kind of shared it with clients, but another thing I think right now, we have one HoloLens in office that we use for some of the development and testing. Obviously, part of the challenge is having a shared experience. And we want eventually to have these tools be more of something that we can collaborate with clients and designers as one space. We'll get there.